A GNexus pattern is a predefined solution that allows us to automatically generate the necessary objects to implement common functionalities. For example, to work with the country entity, it would be useful to have a hierarchy of screens to navigate the information in a structured and logical way. Since this type of interaction is extremely common, having a pattern that automates its implementation saves us significant development time. Let's see how it works in practice. We will apply the work with for web pattern to a transaction. Let's start with country. We go to the Patterns tab, select the Apply on Save checkbox. Save the changes with Ctrl+S and run with F5. GNexus will automatically create all the necessary objects. First of all, we see in the Launchpad that the executable object named country no longer exists. It has been replaced with one named www-country, which stands for Work with Country. When we run it, we access an interface designed to work with countries, offering a set of advanced features. We see a page that lists all registered countries in a grid, and for each country we have two main actions. Update, which allows us to modify the data of the selected country by opening the corresponding transaction, and delete, which allows us to delete a country from here. This will also be done through the transaction. We also have the insert option outside the grid, which enables the entry of a new country, also through the transaction. Let's add United States with the city New York. After confirming, we are returned to the home page, where we can now see the newly added country. We also take advantage of an update in France to add a new city. Nice. In addition, the home page includes a search by name feature. For example, typing F filters countries whose name begins with that letter. We can also click on the country name to access a detailed view of the information. This is divided into two sections. A first tab with all the data of the selected country, and a tab titled City that shows the list of cities associated with the country. From here, we can also update or delete the information by calling the transaction in the corresponding mode, Update or Delete. Finally, we can return to the main list using the countries option. In short, starting from a transaction object, the Work with pattern turns it into a structure that can be navigated with a screen that lists the main information for all elements, in this case, all countries, in a grid, and offers another screen to view the information for one element, the selected one. It also allows the data to be manipulated from both the listing screen and the display screen by calling the transaction itself, but in a much more orderly and hierarchical way. Let's apply the same pattern, but now to the attraction transaction. We can do this by selecting the Apply on Save checkbox, as we did just now with country, or by right-clicking on the transaction. Apply pattern, work with for web. When we save, the set of objects to work with tourist attractions is automatically generated. Let's press F5 to build the application. Now, we run the root object of the hierarchy. In this grid, we see one column for each attribute of transaction information, because all the information fits within the screen width. But if we decrease the width, we see how the information is adjusted until, after a certain limit, it disappears completely and only the most relevant information remains. This is called responsive screen design, and it is what makes screens capable of adapting to different devices and resolutions. Let's insert the Eiffel Tower with all the requested data. This automatic implementation performed by the pattern can be customized in several ways. Let's see some examples. Suppose we don't want the country, city, and category codes to be displayed in the grid. Under the selection node are all the attributes that will be displayed in the grid. To hide them, we simply remove country id, city id, and category id, and save the changes. Let's try it. F5. We can see that those columns have indeed been removed. We can also see that, by default, this field offers the possibility to filter what is displayed in the grid. For example, if we want attractions that start with E, we see that only the Eiffel Tower meets the filter criteria. If we want those that contain mu, in their name we can type %mu, and we see the Louvre Museum. Where is this specified? In the filter section, which shows that for the attraction name attribute, we have this condition. It is this variable and attraction name that appears as a control on the screen so that the user can type there and thus filter the attractions that will be displayed on the grid. If we want to add the possibility for the user to also filter, for example by country name, we right-click on the Attributes node, then click on Select Attributes and add country name. GNexus asks us if we want to define the filter condition, and we say yes. We see that in addition to the attribute, it added the condition by country name. Let's try it. F5. We see that this icon now appears on the right, indicating other filters. When we click on it, this window is displayed, offering to filter by country name. Note that if we type France, only the 2 attractions in that country appear. If we type Czech, it filters the attractions of the country that starts with these letters. In our case, China. Now let's make another observation. By what attribute is the grid of attractions being sorted during execution? It would appear to be by attraction name. Let's check this in GNexus. Indeed, under the Orders node, we find this name order by the attraction name attribute. If we want to allow the user to choose another order, for example, by country name, then we right-click on the Orders node and select Add Order. We name it Country and add country name as an attribute of the order, ascending. Let's try it. F5. Among the filters, we now see this combo box where we can choose which of the 2 possible orders we want. If we choose the order by country, this is how we see the information in the grid. Note that we could request that the information in the grid be sorted according to any of the columns, simply by clicking on it. For example, if we click on attraction name, we see that the information is sorted in ascending order by this attribute. And if we click again, in descending order. The same applies to any column, such as cities. So, why would we want to define orders that are offered in a combo box? In our case, we only have 3 records in the database, so since there are so few, they are displayed on a single screen. The grid has paging by default. If we go to the selection node, we see the paging section. Among other properties, we have the number of rows or records displayed per page. It has the default value, which we don't know yet, but obviously some number greater than or equal to 3. Let's try modifying the property to customize the number of rows, and for example set it to 2. And for the test we want, let's change the order in which it sorts by country name from ascending to descending. We can do this by setting the ascending property to false. Let's see what happens now when we run it. We now see the paging appear. By default, it applies the order by attraction name, which is why the first 2 attractions appear in that order, and on the next page, the remaining one. If we now change the name to Great Wall, removing the order by name would be as shown. So the first page will show the Eiffel Tower in France and Great Wall of China, and the second page will show the Louvre Museum. Note that when we want to sort the attractions by country, clicking on the country name column sorts them by country name, both ascending and descending, but only those we have on this page. It does not consider the Louvre Museum on page 2. On the other hand, if we sort through the order we created, we see that it does sort taking into account all the pages we have and not just the one we are on at the moment. It sorts the one from France first, and then China, which appears on the second screen. France comes before China because remember we set the order to descending. Here, the difference between sorting by clicking on the column to sorting by country name in the external combo box is clear. One sorts by page, and the other takes into account all the records. Let's leave the name The Great Wall as it was. Now let's see what happens to the work with pattern if we change the structure of a transaction. If we add a new attribute in attraction, for example, attraction address, and save it, it will automatically be seen in the pattern instance, and from there, directly on the screen that implements the work with. There is dynamism between the transaction structure and what is generated by the pattern. This means that the pattern remains perfectly synchronized with the structure. Let's note this green icon that indicates just that. Therefore, if we now delete an attribute from the transaction, for example, the one we just added, it disappears from the pattern instance and from the object generated by it. If we directly modify any of the objects generated by the pattern, such as WW attraction, we lose the dynamism. Note that the icon changes from green to red, indicating that dynamism has been lost, and that any changes made to the pattern instance will not be automatically updated here. If we now add the attraction address attribute back to the transaction structure, we see it in the pattern instance, but not in the generated WWW attraction object. The user should never have to manipulate the objects generated by the pattern. They should only work with the pattern definition instance. And if for some reason they need to modify a generated object, from then on they will have to take complete responsibility for the object, because the pattern will no longer do so. To restore the dynamism, we choose Edit, Apply Default. When we do this, the web layout returns to its original state, synchronizing with the transaction and the pattern instance. And in this case, the photo reappears, as does attraction address. We remove attraction address from the transaction structure, and we see that everything is now perfectly synchronized. When we apply the work with pattern, not only are new objects generated, but the transaction is also modified. Let's look at attraction, for example, where rules were added to the rules section, leaving comments so that they are not edited manually. Additional events are also generated, which can be seen in the event section of the transaction source. We will study this section later. If we want to reverse the application of the pattern and delete all the generated objects, we can do it very easily. We locate the pattern instance under the transaction, for example, attraction, and delete that node. This automatically deletes all created objects and clears the Apply on Save checkbox in the Patterns tab. If we want to apply the pattern again, we simply select it again and save. Let's apply the pattern to the rest of the transactions created. This was a brief introduction to the power of patterns in GeneXus.